So this section is talking about something that's very, very important in the manufacturing of products, not only for the company that's making the product, but also for the person that's buying the product. How often have you bought something, or your folks have bought something from, let's say, Amazon, and they get it in the mail and it's defective? Ticks you off because now you have to return it and wait again to get a new one, or it breaks in a short amount of time, and you're kind of stuck with something that's broke then. So one of the things that companies do, manufacturing industries, factories, I've worked in plenty of them over the years, what they have is they have somebody that is in charge of quality control. That means they're controlling the quality of the item that you're buying. So the picture on the page that we've got here are light bulbs. And nothing would tick me off more than you buy a light bulb, you take it home, screw it in, and it doesn't light because it is not a good bulb. It was not checked over, and it wasn't inspected, and it wasn't in good shape. So what they do is they don't check necessarily every single light bulb that's being made. They will look at a certain number of light bulbs and assume that the rest of them are in good shape. So they may grab one just randomly and look at it and make sure it's okay, and then they'll figure that probably the rest of them are in decent shape. So example one, a quality control inspector pulls out, what does he pull out? One out of every 150 light bulbs. Okay, so they're going down a conveyor belt, and he just grabs one out of about 150, and he tests it. If the line produces 27,000 light bulbs per day, how many does he pull out for testing? Okay, so this is a method of using proportions. And the way proportions work is, let's get some blue here. He pulls out one for every 150 bulbs that go by. So we're going to make that into a fraction, 1 over 150. We are going to find out how many bulbs he checks if we have 27,000 bulbs go by. So the ratio is 1 for every 150. Well, if it's 1 for every 150, how many is it for 27,000? Well, the ratio is basically, we've got two fractions here. This is the reduced fraction. This is the fraction that needs to be reduced. So for example, like when you have a fraction like 2/4, that reduces to 1/2. That's the same thing. We're just taking two fractions and finding out what this top number is so that it's equal to this one. So I said equal, we're going to put an equal sign right there. All right, so the way you do proportions, if you have two fractions and one of the numbers right here you don't know, this is the way you solve it. I'm going to draw this here, and I draw this here. Those are the things we're going to multiply, so let me get rid of those. We're going to take 1 times 27,000, and that's going to equal 150 times what we don't know. Let's call it n for the number of light bulbs we don't know. And that's all that n represents. It just means that we don't know what number that is at this point. Okay? So, what we're going to do here is, if you remember simple algebra from back when you were in middle school, if you are trying to get this number all by itself and this number is being multiplied, you divide by that, and you divide this side by that. And this 150 over 150 goes away. So now you have 27,000 divided by 150. And when you do that, you get a number, and let's see if I can erase. It won't let me erase. I get a number up here on top, I'll just do it in red, of 180. So, as the day's going by, 27,000 light bulbs go by, and you're the inspector to pull light bulbs to test them. Throughout that day, you're going to pull 180. So 180 over 27,000 reduces to 1 over 150. So this is the ratio we're looking for. Given this many bulbs, that's the number that we're pulling out to test. That works on every one of these. Okay, so let's see if I can get rid of my drawings here. Okay, for example number 2, on a given day, a quality control inspector found 2 defective bulbs out of 115. So let's go ahead and write that. 2 out of 115. So for every 115, he found 2. If the day's total production was 22,500 bulbs, predict how many of those bulbs were defective. So again, we've got a fraction here, 2 over 115. That is going to equal the number we don't know over 22,500. Okay, so that will tell me how many bulbs were defective out of 22,500 if 2 were out of 115. So again, we're going to do what we did on the last one. We're going to multiply the 2 times 22,500. We're going to leave this equal sign there, and we're going to take 115 and put it with the n. Okay, so we went this way, and we went this way. So 2 times 22,500 is 45,000. That equals 115 n. We divide by 115 because we want to get rid of those two numbers. We divide this number by 115, and we get for an answer 391.304. Now we can't have a 0.304. We can't have that many light bulbs. So we just round it to about 391 light bulbs out of the 22,500 were defective. Hopefully, when you buy your light bulbs, you're not one of those 391 people who's going to get a bad light bulb. So anyway, that is the manufacturing process on page 99. Let's jump to page 100. All right, top of page 100. Example 3. A company produces toaster oven tries to inspect 5% of the 2,500 toaster ovens they produce. If the company can tolerate a defective rate of no more than 1%, that means they do not want there to be more than 1% of the toaster ovens that are defective. How many toaster ovens can acceptably be found to be defective during a given day? So that means out of all of the toaster ovens they produce every day, 2,500, how many of these toaster ovens could be defective and the company be okay with it? Because you can't be perfect. They have to know that we're human and that there's going to be some problems with our toaster ovens. So 2,500 we're going to make. We are able to have 1% of them be bad, and then we can decide whether or not it's a big enough number to cause us problems or not. So 1% we're allowed. If it's 1%, we had a good day. So what we're going to do here, we're going to look at how many we inspect. 5% of the 2,500. Remember, of means multiply. So 5% of 2,500, that's how many were inspected. So that's what we're going to find out first, because we don't know how many defective ones there are that we don't inspect. We can only look at the ones we inspect. So we're going to take 2,500 times 5%. Now, if you remember from units past, we can't do anything with that 5% because of the percent. So we have to change it to a decimal. Remember decimals? We move the decimal point from here over 2. And then we can take the percent sign off. So 2,500 times 5% means that we actually inspected 125 toaster ovens. That's 5% of the amount we had per day. So that isn't how many are bad. That's just how many we pulled off the line that day and looked at to find out how many toaster ovens were defective. So we're looking now at that number 125, and we're interested in 1% of that because that's how many can be defective. So let's say that I'm a quality control inspector. I'm on the line. I pull off 125 toaster ovens and test them. Well, the president says you can have 1% of that 125 not be any good. So what do? I take 125 and I multiply it by 1%, and that tells me how many I'm allowed to have as defective. Now again, 1% cannot be multiplied, so I have to change it to a decimal. Move the decimal place over 2, and that gives me 1.25. So what does that tell me? I am allowed 1 toaster oven for every 125 toasters I pull off. That means every day, as those toaster ovens are going down the line, 2,500 are going to go, I'm going to pull off 125 because that's 5% of them. That's how many are inspected. And out of those 125, I better not have more than 1 that doesn't work, or I'm in trouble, or the person that's making them is in trouble. So that's how you figure that out. And go ahead and there really isn't anything else in this lesson except just hearing me talk about it. But I would like you to look at number 1, think about it on the bottom of page 100 and do that. But then we get into the practice on page 101 and 102, and I'll make a video over that.